Okay, in section 5 today we are going to be worrying about graphing in slope-intercept form. So we have to find the slope and y-intercept of a line. Slope-intercept form, which is what this whole section is about, helps us find both. The form is y equals mx plus b. Now in the last section we talked about how m represents the slope. And in this equation our b is going to represent our y-intercept. Okay, so from some functions that are already in slope-intercept form, or we need to get them in slope-intercept form and then identify what the slope and the y-intercept of the line are. So in part A, our slope is 3 and our y-intercept is 0, 4. I would prefer you writing it like that instead of just 4 because the y-intercept is a point on the y-axis. On B, we need to get it into y equals mx plus b form, so we need to solve for y. Get that 3x over. Y equals negative 3x plus 2. Slope, our m is negative 3, and our y-intercept is 0, 2. Part C, we need to solve it for y. So first I'm going to subtract 3x from both sides. So we have negative 3y equals negative 3x plus 12. Next step we need to do is divide by negative 3 to get that y alone. So y equals 1x minus 4. So our slope is the number in front of the x, which in this case is just 1, and our y-intercept is 0, negative 4. D, we need to solve for y as well, so we're going to subtract the x first. 4y equals negative x plus 6. We need to divide both sides by 4 to get the y alone. Y equals negative 1/4 x plus 6/4. So our slope is negative 1/4. Notice how we leave it in a fraction, so that slope is in rise over run form, and our y-intercept, 6/4 can be simplified to 3/2. Okay, graph the equation 2x plus y equals 3 using slope-intercept form. So the last thing that we did for graphing was use the both intercepts, so we solved for x, solved for y, and just found the intercepts and graphed it. This time we're going to find the slope and the y-intercept. So we need to get it in y equals mx plus b form, which means we need to subtract 2x from both sides. Y equals negative 2x plus 3. So our slope is negative 2, and our y-intercept is 0, 3. It's important to note maybe that when our slope is negative 2, that's the same thing as negative 2 over 1. That's going to help us when we figure out rise over run. So the first thing that we do is find the y-intercept, which is 0, 3. And then we're going to use the slope, negative 2 over 1, to go from 3. So if it's negative 2, that means down for our rise. 1, 2. And if it's a positive 1 on the bottom, we have to go over 1. 1, 2, 1. 1, 2, 1. Okay, here's a word problem. To get from one floor to another in a library, you can either take the stairs or the escalator. You can climb the stairs at a rate of 1.75 feet per second, and the escalator rises at 2 feet per second. You have to travel a vertical distance of 28 feet. The equations model the vertical distance you have to travel after d seconds. You have stairs and the escalator, two different equations. So it wants you to graph the equations in the same coordinate plane. How much time do you save by taking the escalator? So we need to, they're already in slope-intercept form. So we need to make our axes. I'm going to go by 4s on the y-axis We have to get up to 28 on both of them. And x's, I'm going to go by 4s as well, just keep it consistent. Okay, so we need to, let's do, the stairs is going to be red. So we need to find the t-intercept, I guess, in this case. Instead of x and y, it's d and t. T and d. So our t-intercept is, our d-intercept is 28 and negative 1.75. We need to write this as a fraction so we know what rise over run is. That is 7/4. So we need to go down 7/4, which is about right there. This is a little crooked. I'm just going to try again. There we go. The other one I'm going to make blue. You can keep track. Same d-intercept at 28, only it goes down 2/1 for our rise over run. Okay, so that is as straight as I could possibly go. That was graphing them, part A. And how much time do you save by taking the escalator? Well, the escalator is the blue one, and it looks like it's about 2. And we're in seconds, so about 2 seconds. That's for part B. Okay, a television company produced two 30-second commercials, one for $300,000 and the second was $400,000. Each airing of either commercial on a particular station costs $150. The cost to produce the first commercial and air it is given by this function. C equals 150 n plus 300, and the cost to produce the second and air it is given by this second function. Graph both in the same coordinate planes. Okay, so again we need to make our axes. Okay, this is our N, this is our C. So I think I'm going to go by 1s on the bottom, that's our number of airings. That's an 11, it's not letting me write down there. I'll write that on the bottom, this is airings. There we go. And the cost, I am going to make a little jump. Start right here at 200 and then go by 100s. I guess we didn't really need the jump, did we? Just going by 100s. Let's take that out so we don't get confused. Okay. Alrighty, so now we need to graph both of them. Let's see what colors we picked. The top one is blue, 150 plus 300. So we start at 300. And our slope is 150, so that's 150 over 1. So up 300 over 2, I think would be a little easier. Okay, so there's our blue equation. Second one is 400. Oops. First one. Second one starts at 400. Okay, based on the graphs, what is the difference of the cost to produce each commercial and air it two times, sorry. Between 2 times, the difference is $100,000 every single time. And this is going to bring us into our last thing for the section, which is parallel lines. We notice that the slope is the same on this previous problem. As it is with every parallel lines. Okay, so here we have 3 lines, A, B, and C. It wants us to figure out which of those lines are parallel. So we're trying to figure out which of those lines have the same slope. Now, honestly, they all look parallel to me, but we need to find the slopes of those points. So for line A, our points are -1, -1, and 2, 0. The slope of that line is 0 minus -1 over 2 minus -1, which is 1/3. B, our points are 0, -3, and 6, -1. Our slope is -1 minus -3 over 6 minus 0, which is 2/5. No, sorry. -1 minus -3 is 2 over 6. 1/3. And C, our points are -2, -5, and 4, -3. So our slope is -3 minus -5 over 4 minus -2, which is 2 over 6, or 1/3. So I was correct in my suspicions. They are all parallel. Okay, and that was section 4.5.